So we begin our study of market failure with the concept of an externality, which is present whenever the well-being or the utility of a consumer or a firm is directly impacted or affected by another agent in the economy. So we could, for example, define as H the action taken by a consumer that affects other consumers in the economy. So this is the externality level. If we consider a very simple economy with two consumers, let's assume, for example, that the first consumer is producing the externality, which is affecting the other consumer. So what is, for each consumer, what is the utility function associated with this externality level? So you consider L goods that are traded. And now for consumer I, you can define the utility function of consumer I, which is a function of the level of consumption of the L traded goods. So we go from X1 to XL. We have to index this for each consumer. But we're missing something. We're missing the externality level H, which is folded into the utility function. So the problem for each consumer is to maximize this utility level, maximize U of I. Let's just use a very simple notation here. Let's refer to all of these as consumption levels as simply one vector xi. And here is h. So we have to maximize our utility such that there's a budget constraint, pxi, which has to be lesser than or equal to the wealth of the particular consumer. And we also impose the constraint here that xi is a positive vector. In other words, we must consume a little bit of each good. Oh, I'm sorry. We must consume a little bit, at least a little bit of something for one good. So we cannot consume nothing. Nothing at all. We have to consume at least a little bit of something for at least one good. And we cannot have negative consumption for the other goods. In order to simplify the analysis for expositional purposes, the textbook, Maskell, Winston, and Green, assumes that the indirect utility function, i.e. the maximum utility that an agent can get, VI given a certain price system in place, given the endowments, and given the externality level, that takes on a quasi-linear form. So this is equal to a function phi defined over prices and the externality level plus the particular endowment for each consumer. And this is essentially rules out income effect. So we could freely transfer wealth from one individual to the other without affecting the total utility being generated in society. Here are a couple of assumptions that we're making with respect to the function phi. So it's twice differentiable. And we're assuming here that the second order derivative is negative. So what does it mean? It means that the first order derivative is decreasing. So there's some concavity there. Further, we are also assuming that if we are dealing with a negative externality, for example, I play very loud music during the night and my neighbor can't sleep. That's a negative externality in the sense that the production of loud music by me will actually reduce the utility being enjoyed by my neighbor. So it has a negative impact on the utility of my neighbor. So if we have a negative externality, then phi prime, the first order derivative of phi for my neighbor, i.e. for the person being affected by the externality. So if we're talking about a very simple situation with two consumers, consumer 1 is producing the externality, consumer 2 is being affected. Here, phi prime for the second person would be negative. And in the event of a positive externality, for example, like paint my house, and now my house looks very pretty and everybody on the block gets to see it, and it makes them feel better about living where they're living. So they get some pleasure from that. In that situation, the first order derivative would be positive. Okay, so what we're trying to show here is that the competitive outcome is not optimal, meaning that the externality level H, which is being generated by consumer 1, first consumer, in a competitive process where each consumer is maximizing utility, well, that level will not result in a Pareto optimal allocation. So let's derive this. Now, if you are at a competitive equilibrium where each consumer is maximizing his or her utility subject to a budget constraint, then it must be the case that the level of the externality level, which has been chosen, is maximizing the utility function, which takes the form of a quasi-linear form, the form of phi of I plus, plus the endowment. So if this is being maximized, it must be the case that the equilibrium level of H, let's call it H star, where each consumer is maximizing his or her utility, will satisfy a first order condition that the first order derivative of phi with respect to H must be negative or equal to 0 if we allow for a boundary solution, but if we limit ourselves to a situation where we have an interior solution, then we simply have the first order derivative equal to 0, assuming that H star is strictly positive. Okay, so that would be the first order condition for a situation where each consumer is optimizing his or her utility. Now, on the other hand, if we have a Pareto optimal allocation where the externality is set at its optimal level, and we call this H with a little bubble here, then in this Pareto optimal allocation, H was chosen so as to maximize the joint surplus. In other words, phi 1 plus phi 2. And as we've seen in the discussion that relates to partial equilibrium, it is sufficient to, in an economy where the utility function takes on a quasi-linear form with respect to the numeraire, it is sufficient to maximize the surplus. In other words, the terms plus the endowment of the first consumer and the endowment of the second consumers, these will drop out. They are essentially irrelevant because we can freely reallocate wealth or endowments between consumers without affecting the total amount of utility which is generated in the economy. So I'm just going to remove these. And we can now very easily see that the first order condition here in this economy would be as follows. which would be that the first order derivative plus for the first consumer and the first order derivative for the second consumer has to be negative or equal to 0. And if we, so let me rewrite this. And this condition becomes, if we limit ourselves to an interior solution, simple equality. And we can now see how this condition here is different from the condition that the first order derivative of phi for the first consumer be equal to 0, which is what you get when each consumer is maximizing utility separately, right? So if we're maximizing utility jointly, from the perspective of a social planner, we get this first order condition. So it is obvious here that the optimal level will not be the same as the level that results from a competitive outcome. So in other words, when there are externalities, the equilibrium level for H is not optimal unless, of course, H star is equal to 0. So there is no externality being generated. So if we consider a negative externality, then the marginal utility to person 2 is negative. So for the first person, what can we say about this? The marginal utility being measured at the competitive outcome level H star, well, that's equal to 0. That's the first order condition. And then the marginal utility for person 1 evaluated at the optimal, Pareto optimal level. What do we know about it? We know that it's positive, and that's also from the first order condition. So if we draw the relationship here between H and phi prime, marginal utility, we can say that for person 2, that it's the marginal utility is always negative. So if we map the opposite of that, i.e. the disutility level, negative phi prime for person 2 as a function of 8, it's an increasing function like this. And if we map the marginal utility for person 1, phi pri 1, oops, we get something like this for person 1. The point here where it's equal to 0 is H star. And the point here where it's equal to the marginal disutility for person 2, this here, that's the Pareto optimal outcome, and we see here that H star, Pareto optimal result is less than H star. So the person left to do its own optimizing will choose to produce an externality level H star, which is actually greater than the optimal level. And we can show the converse result holds for a positive externality, where instead we get something like this. If we map out the relationship between H and marginal utility as a function of H, we get negative phi prime for person 2. This is the disutility here. And then we get something like this for person 1. This is phi prime for person 1. This point here where it's phi prime for person 1 is equal to 0, this is the competitive level. as per the first order condition, and this point, here, sorry, this is Pareto optimal level where these two lines intersect right here, and now we have the result that the competitive level is actually less than the Pareto optimal level. And so when you have a positive externality, the person 1 will choose to produce less than the Pareto optimal level.